All right, the first thing that you're going to do is you're going to group your x and y terms. You put your variable terms on one side of the equation, you put your constants over on the other side. So what that's going to look like is, and you'll put them in alphabetical order, so x squared minus 6x, I'm grouping, reordering those terms and grouping them together. I am going to leave a space to do the next step. Okay, so now I group my y terms, y squared plus 8y, again leave a space to complete my next step. And then I'm going to move my 2 over to the other side. So it becomes a positive 2 when I move that over. So this is step 1. We group our x and y terms, move them to one side of the equation, and then put all the constants over on the other side. Step 2 is called completing the square. Hopefully you guys recall this from algebra. It's one of the ways to solve quadratic equations. Okay, and what we're going to do here is we're going to complete the square for the x's and for the y's individually, and then so that allows us to rewrite it in the form of the equation of a circle. So here's what completing the square involves. Okay, the first thing you're going to do is you're going to take 1/2 of the first degree term, its coefficient. All right, so if you don't recall, when you name individual terms, you can classify them by degree, and the degree is simply the power or sum of powers of the variables in the term. So when we look at this, x squared has a degree of 2 because its power is 2. X to the first has a degree of 1, a second degree term, first degree term, and constants have a degree of 0, or again, I'll just refer to them as constants. Okay, so you're going to take 1/2 of the first degree term's coefficient. So in that case, for the x's, what is 1/2 of -6? -3. You're then going to square it. So what is -3 squared? 9. And then you're going to add it to both sides of the equation. Okay, so when we complete the square here, we take 1/2 of -6, which is -3, square it, we get +9. We're going to add that, since we added it to the left side of the equation, we need to balance the equation by adding it to the right side as well. Okay. What that allows us to do, and I'll come back and we'll do the same thing with the y's, but what it allows us to do here is it allows us to rewrite our expressions as binomial squares. And so this whole thing, the x squared minus 6x plus 9, the whole point of completing the square is it allows us to rewrite this as a binomial square. Our first term is going to be x. Our second term is going to be whatever half of that first degree term's coefficient was. So the number that we squared to get plus 9 is what our second term becomes. So 1/2 of -6 was a -3. And so this is our binomial square form of this same, what's called a perfect square trinomial. Okay, so we're going to do the same thing with the y's. Okay, take 1/2 of our first degree term's coefficient, so 1/2 of +8 is plus 4. We square it. Squaring 4 gives us 16. We're going to add that to both sides of our equation. What that then allows us to do down here is it allows us to rewrite this as a binomial square. First term y, the second term was 1/2 of that first degree term's coefficient. So 1/2 of +8 was plus 4. And then we just simplify what we have over here. So 2 plus 9 is 11 plus 16 gives us 27. And so here is our equation. Okay. Our final step, depending on what's being asked, is to interpret the equation of a circle. And so here, if we find our center, what are the coordinates for our center here? What value of x gives us a 0 in this expression? And what value of y gives us a 0? Okay, so there's the coordinates of our center. And then our radius is going to equal the square root of this number. And now, you always do need to make sure that you reduce. Are there any perfect square factors you can remove from 27? 9 times 3, the square root of 9 comes out as a 3, and it leaves a factor of 3 inside as well. And so you have your center and your radius for this problem.